Hello students, welcome to BioWise with Aanchal. Now today I am going to address a query that one of my student has given in the comment section. Now the child has given the question that why do potassium has the electronic configuration of 2881 and not 289. So we are going to solve this query. Before going into the detail of this query, you are requested to subscribe the channel and watch the video till end to have a better understanding of electronic configuration. Now the question was, potassium, the atomic number is 19, mass number is 39, has the electronic configuration of 2881 and not 289. Now as we have studied the Bohr-Bury's law that there is a formula to find out the maximum capacity of the electrons in the orbits. So according to this formula, if we go, there are 4 shells, you all know that, right? The K shell, here n value is 1. So 2 into 1 square, the output is 2 electrons. The L shell, the n value is 2. So 2 into 2 square, that is equal to 2 to the 4, 4 to the 8. M shell, n value is 3. 2 to the power 3 square, that is equal to 3 3 is 9, 9 2 is 18. And the N shell 4, that is 2 into 4 to the power 2, that is 4 for the 16, 2 is the 32. So according to the law of Bohr and Bury, the number of electrons that can fit in K shell is 2, L shell is 8, M shell is 18 and N shell is 32. Correct? Now my question is, since the capacity of M shell is 18, then why is 8 written for M shell and why not 9? So let us answer this question. Before that, let me clear the board. According to the modern atomic theory, we have orbitals instead of orbits. Now to understand the concept of orbitals, I cannot go in deep explanation of the orbitals to you, because for standard 6, 7, 8, 9 and 10, basically we do not study about the orbitals, right? SPDF and all is not there in our syllabus. But there is a need of understanding SPDF for few explanations, that is variable valency and also about the potassium and calcium electronic configuration. Now when we talk about orbitals, understand this children, okay? For n is equal to 1, that is your K shell, it has got one orbital which is called S. Right. Now S orbital can have only 2 electrons in it. So this explains the Bohr-Bury's law of K shell having, this is according to the Bohr-Bury, that is the K shell should have 2 electrons. Understood? Similarly, when n is equal to 2, the L shell has got 2 orbitals. One is S, another is P. The capacity of S is 2 and that of P is 6. So total it makes 8. According to the Bohr-Bury's law, 2n square makes 8. Okay. Then n is equal to 3 for M shell. M has got 3 orbitals, S, P and D. S has the capacity of 2, P has the capacity of 6 and D has the capacity of 10. This makes total of 18. According to the Bohr-Bury's law, 2n square, for M shell we have 18 electrons. Similarly, when n is equal to 4, that is your KLM N shell, it has got 4 orbitals, S, P, D and F. S has got 2, P has got 6, D has got 10 and F has got 14 electrons capacity, making it 32. That is same as the number of 2n square, 32. Is this concept understood? Once again, K shell has got only one orbital. L has got 2, S and P. M has got 3, SPD, and N has got SPDF, 4 orbitals. So, seeing the capacity, just understand it like benches. S has one bench, right? So, it has got 2 electrons capacity. P has got 3 benches. So, it has got 1, 2, 3, 4, 5, 6 electrons capacity. D has got 5 benches. Okay, 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is how the electrons are arranged. Similarly, F has got 7 benches, each accommodating to, there are 14 electrons. So, this is how we explain the capacity. Even the Bohr-Bury law gave us 2n square, which proves the same number. Now, the question is, for first 2 shell is not an issue. For first 2 shells is not a problem. For M shell, the capacity is 18. The electrons have to sit in 3 different orbitals. Now, you have to understand that the lowest energy orbitals are filled first, and then it goes to the higher energy and higher energy. Is that clear? So, let me clear the board. Now, we have to understand the level of energy, how the electrons fill the orbitals. So, for that we need to know the basic concept, that is KLMN shell. So, K shell, where N value is 1, it has got only one S. N value is 2, that is for L, it has got 2S and 2P. N value is 3 for M shell. So, you have 3S, 3P, 3D, 3D. For N is equal to 4, that is N shell, you have 4S, 4P, 4D and 4F. This much is more than enough to understand your concept. Now, the energy level. The first lowest energy is 1S. Okay. Next one is 2S. Next one is 2P, 3S. Next one is 3P and 4S. Next is 3D and 4P. I hope you have noticed that here first 3p orbital is getting filled, and then the electrons are moving to the 4s orbital, that is from the KLM shell they are moving to N shell, and once N shell is full, then only they are going back to the M shell. So, that is the reason why potassium has 8 electrons. We will see that. Is this clear first? I will just erase the board. I have not rubbed this because I wanted you to calculate the number of electrons. Okay. Now, see, potassium has got the electronic configuration of, that is number of electrons as 19. Electrons present is 19. So, you have to divide these 19 electrons in KLMN shell. KLMN shell. Is that clear? Now, what happens? First orbital of K shell. This is the orbital of L shell. This is the orbital of M shell. Then you are getting N, and then it goes to M again. Now, 2 electrons plus 2 electrons, 2 plus 2 4, plus 6 electrons 10, 10 plus 2 12, 12 plus 6 18 and 1 is left. So 1s is 19. So what does it mean? K shell has got 2 electrons, L has got 8 electrons, M has got 6 plus 2, 8 electrons, and S, that is N shell, 4th number, has got 1 electron. That explains the electronic configuration of potassium. Is that clear? Similarly, when you talk about calcium, atomic number 20, mass number 40, number of electrons is 20. So K, L, M and N. So now in this case, capacity of S is 2, capacity 2, 6, 2, 6, that is 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18, 19, 20. So 20 electrons are distributed. So you have K may you have got 2, L may you have got 8, M may you have got 8 and N may you have got 2. That explains the electronic configuration of calcium. Is that clear? Why it is not 2, 8, 9, why it is not 2, 8, 10, rather it is 2, 8, 8, 1 and 2, 8, 8, 2. Is that clear? Now this also explains variable valency, right? Because we cannot explain variable valency using the electronic configuration only of 288, right? So this can explain the variable valency. I will just give one example and I will wind up. Let me clear the board first. Now let us take an example of iron. Fe, atomic number is 26. Simple process, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, that is 2 plus 2, 4 plus 6, 10, 11, 12, 18, 19, 20, 6. Okay. Now you have to understand, as I told you, benches can have the capacity of 2. So any bench or any orbital is stable if it has completely filled electron or it has got half filled electron. So here you can see the capacity of D is 10 and it has got 6. Okay. So it has a tendency to donate that extra 1 so that this D becomes 5. Okay. But as with the concept of valency, what was the concept of valency? Valency depends upon the valence number of electrons, that is in the outermost orbit. Outermost orbit is 4. 4, you can easily lose 2 electrons. So here you can lose 2 electrons plus 1 more electron you can lose extra. So when iron loses 2 electrons, it forms ferrous iron, and when iron loses 3 electrons, 3 electrons means 4s2 and 3d say 1, making 3d, that is 1 electron is lost. So the new stable configuration is 3d5 and 4s0. So you have got 3 electrons lost. So you have the valency for iron as 3d, 3 plus. You have the valency for iron as 3 plus, that is ferric iron. So this electronic configuration explains variable valency. Okay. If you have any doubt related to this topic, kindly put it in the comment section. Like, share and subscribe if you really think it's worth sharing. Thank you so much children. Happy learning.